ازيك يا صبا؟
الحمد لله.
عاملة ايه؟
الحمد لله.
جاهزة؟
اه.
يلا. We talked about the particles and we said that anything around us is a matter. Anything that has mass and takes up space, we call it a matter. And then we take the properties of the different materials, and then we talked about the history of the matter and how the Greek philosophers can understand everything around them, and they give their theories and what they think about the matter. Today we'll continue, and we found that Democritus thought was true, and that everything around us is made up of particles or small particles. Everything around us is a matter, and the matter consists of small particles. We call it atom. It's very small. It can't be we can divide the atom. It is the smallest building unit or the smallest part of the matter. Okay, so Democritus had the right idea that everything around us made up of small particles, and the matter consists of these small particles. صعبة انت معايا؟
ايوه.
We now know that all materials are made of a very small pieces of something that cannot be cut up. These small particles, we cannot cut it up any smaller. It is the smallest part, or the smallest particle that we can divide the matter to. The matter only can divide it to smaller and smaller pieces until we reach these small particles. We cannot cut them anymore. Okay, Sabah? All these pieces, or these small pieces, we call them particles. All particles have mass, as we said. Everything around us has a mass and take up space, have mass and have volume. We call it a matter. All the particles have mass and take up space, which means they have volume also, but not very much. أخدنا الصفحة دي؟
ايوه.
أخدناها. طب قولي لي. سوري يا صاحبي. احنا أخدنا الصفحة دي وعرفنا it's okay إن ال particles we can cut them and they have mass and have volume. Okay, today we will talk about the particles in the matter, and we'll talk about the solid, especially the solid. The solid are one state from the states of the matter. They are hard. Can you tell me the properties of the solid matter, Sabah? Sabah?
Yes.
Yes, can you tell me the properties of the solid matter?
We didn't take this one.
We talked about it at the first part of the unit. That the solids
okay.
are hard, they have definite shape and have definite volume.
Yeah.
Yes?
Yes.
You remember this?
Okay, yeah, I remember now.
Yes. So the particles are the state of the matter that have definite shape. Its shape doesn't change when we move it from one place to another. If I have a pen and I move the pen from one place to another place, it keeps its shape. So it has definite shape and definite volume and definite mass. And it is the hard state of the matter. The matter which is hard and keep its shape. It doesn't need a container to hold it. It can stay the same with its shape, and we can move it from one place to another easily because it can keep its shape. Okay? This was the properties of the solid matter. Okay? So,
Okay.
although some solids can be squashed, we can cut solid things. Apple is a solid state matter. We can cut it with a knife. The paper is a solid state matter. We can cut it. So the solid
With the scissors.
with the scissors, very good. So the solid can be squashed and can change shape. Why do they keep their masses and volume? Why the mass and the volume of the solid are the same, or the solid can keep their mass and can keep their volume and shape? The shape can be changed if we cut them, but they can keep their mass and keep their volume. He tried to tell us to imagine that we can look at the particles. If we can look to the particle or look at the particles of the solid state matter, what we can see? Can you imagine the particles of the solids? قلتي حاجة ولا أنا مش سامعاكي؟
The particles?
Yes, particles of the solid. Can you imagine their shape, their arrangement?
Big.
Particles are big.
No, I listened the something the particles is small.
The particles are small. All the particles
Yeah.
are small. Particles of solid or liquid or gas, they are all small. We can see them with our eyes. Okay, scientists believe that the particles are arranged in different ways in different states of matter. The arrangement of the particle in each state differ. The arrangement of the particles in the solid state matter is different from the arrangement of the particles of the liquid. And the arrangement of particles of solid and liquid differ from the arrangement of the particles of the gas. So each state of matter, its particle is arranged in different ways because they are different. Okay? So their particles must be different. The arrangement of their particles must be different. The scientists believe in this idea. The scientists believe that the particles are arranged in different ways in different state of matter. If each state of matter, its particle is arranged in different way. This theory or scientific idea is called the particle model. They give it the name of particle model. What is the particle model, Sawa? What is the particle model? The particle model is that the particles are arranged in different ways in different state of matter. This idea is called the particle model. So can you tell me what is the particle model?
Particles are arranged in different ways in different states of matter.
Yes. This is called the particle model. The scientists called it the particle model, that every state of the matter or each state of matter, its particle is arranged in different ways. Now we will talk about the arrangement of the particles of the solid state of matter. Okay? So here we are talking about the solid state. Let's explore how the particles are arranged in a solid. Read the text in the box below. Use it to draw a model of how you think the particles are arranged in a solid. This is a box. He is telling inside it the features or the aspects of the particles of the solid. He gave me what is the particles of the solid look like. So we can think of particles as tiny spheres. These particles we can think of it as a tiny sphere, like this one, tiny sphere, or ball shaped. Imagine them as all being the same size. All the particles have the same size. Okay? In a solid, they are very tightly baked, and they are close to each other. They are very, very close to each other. So they are very tightly baked together. They are arranged neatly in rows. They are arranged in rows behind each other or beside each other. They are arranged in rows, each row one on top of another. Each row is above the other row. They are not still. They are not stay at their places, they are vibrating. There is a type of movement in the particles of the solid in a vibrating movement or vibrating motion or shaking on the spot. So these are what we imagine about the tiny particles of the solid. Their shape is a sphere-like or a ball-like shape. They are tightly baked together. They are very close to each other. They are arranged in a neatly. They are arranged very. They are so arranged together. Each one is over the other and near the other in an arranged form. They are not randomly. They are not around each other in random way. They are arranged in rows, and each row one on top of the another. Each row is over another row, and the third row is over the second one. They are arranged in rows, and they are vibrating or shaking. Okay, Saba?
Okay.
This is the properties or the features of the particles of the solid. Okay?
Okay.
Okay. He is he's asking me about these three particles. Three learners read the information about solid above. They each drew their own model. Two of these models have mistakes. One is correct. There are three models. After they listen to these properties, they draw these three models. He is asking me, two of them have mistakes and one is correct. Can you recognize the correct one and tell me which two models have mistakes?
C is not correct
Why?
because it's big. The particles is small.
Small? Small? You are saying small?
Yes, the particles are small.
All particles
Rectangle.
are small.
Yes,
All particles are small. It's not the reason. Is it the correct one or it's the false one?
not the correct.
C is the correct one?
No, it's not the correct one.
Yes. Why it is incorrect?
Because it's so big, the particles are so small.
Okay, this is the model. It's not the real
Yeah.
particle. We are
Yes.
drawing a model to represent the particles. The particles are very, very small. We can see them. So we draw this model to represent the particles. So it's small or big, it's not the reason. They are big because we draw them with our hands. They are in real, they are very small. In real, they are very small. This is the model. A model is a copy of the particles. We make it big so we can see them. Understanding me, Saba?
Yes.
Okay. This one is incorrect because the particles are not tightly baked. Tightly baked is to be near each other. They are very, very close to each other. These particles have spaces between them. Can you see this? And they are
Yes.
not arranged. They are randomly arranged. They are in random form. Every particle is in a random arrangement. What about A?
A
Is it correct or incorrect?
correct.
Why it is correct?
Because
They have different shapes. There is small particles and big particles. And it is wrong. All the particles are in the same size. All the particles have the same size. There is no small particles and big particles. Okay? Okay. B model is the correct model because they draw it in the correct way. We can see together why it is correct. First thing, they are tightly baked. They are arranged. Each one is close, very, very close to the other. This is the first property. They are sphere in shape. It's okay, it's right. They are all in same size. Okay. They are arranged neatly in rows. This row, over it another row, and another row, and another row. So they are arranged neatly in rows, and each row one on top of another. This row is in the top of this row, and this row is in the top of this row. And they are vibrating. These lines represent that it is vibrating. Can you see these small lines around the particles?
Yes.
It's representing that the particles is a vibrating particles or are shaking. So this one is the correct one. P is the correct model. A is the incorrect model because the particles, we have some particles which is big and other particles which is small. But we have in the solid state matter all the particles are in the same size. بتقولي حاجة؟
إيه؟
بتقولي حاجة؟
لا.
Okay. So these particles, some of them are small and the other are big. So it is incorrect. And they are not vibrating. They are still in their place. There isn't vibrating in this model. In this model, it is incorrect also, but it is incorrect because they are not tightly baked. They have spaces between them. They are not neatly arranged some. Okay? Okay, Saba?
Yes.
Yes. So the particles of the solid are a sphere in shape, and they are in the same size. They are tightly baked together. They are arranged neatly in rows, and they are vibrating. This is the properties of the particles of the solid state of the matter. Okay, Saba?
Okay.
Okay. Here is the photo for the particles or a model that represents the particles of the solid. Can you see them? They are arranged very neatly over each other. They are very close to each other and vibrating. This is why the solid state matter can keep their shape, because the particles that make the solid state matter are close to each other. So they can keep their shape. When we put them in any surface, they still as they them. Its shape doesn't change. In a solid, each particle is held in place very tightly. Each particle stays in its place. It vibrates in its place, but it's still in its place. The particles are in fixed position. Their position is fixed. Each particle alone, this particle cannot move alone. And this one cannot move alone. They move all together as a vibrating. Its movement is vibrating movement. So the particles held in place very tightly. They are fixed in position. Their position is fixed and cannot move. They cannot move even around each other. They cannot move around each other. Even this movement, they can't make it. They can only vibrate in their place or in their position. They can only vibrate. Special pulling forces hold particles close together. What's the meaning of pulling? This one. Word.
Pulling. It's,
Pulling force.
coming to him or come to him.
Yes, to
Pulling
bring something
Yeah.
near you. This is a pulling
Yes.
force. Like when you are pulling a car toy. This is called a pulling force. There is a pulling force between these particles. Each particle and the particle next to it, they have a pulling force between them. And each particle of the solid particles contain between them this pulling force. So the particles are held tightly because there is a pulling force between the particles. Make them close to each other. Make them stay in their places. Each one stay next to the next particle. They are all stay together. There is a force between them that keep them all arranged and stay next to each other. Each particle pulls other particle towards it. This one pulls this one towards it, and this one pulls this one, and this one pulls this one. Each particle from these particle of the solid state of matter pull the other particle towards it. so that they are tightly baked. As a result, for this pulling force, these particles are tightly baked. They are all close to each other. The particles cannot escape from a solid. One particle is this particle or this particle. There is no particle which can escape or can move alone. They are very close to each other. They have forces that make them all of them near each other. Okay?
Okay.
The particles cannot escape from a solid, so the mass and volume of the solid stay the same. This is why when we put any solid state matter in its place, it stays as it is. It keeps its shape. It doesn't flow like the liquid. Because the particles are tightly baked, they have forces between them that pull each particle next to or towards the other particle. They are fixed in position. They are held in place very tightly. They can only vibrate in each place. This is why the solid state matter can keep their shape and keep their mass and keep their volume. Okay? Okay. Solids cannot be squashed into a smaller shape. If it is, we can't squash it to a smaller shape with our hands. If you have a mobile phone, can you squash it by your hands? No. We need a knife or need a saw to cut it. But if we left it alone, it stays with its shape and stay with its volume and mass. Their particles are already closely baked together. They are baked together, يعني tightly baked, يعني are near each other. The particles themselves cannot be squashed or stretched. This particle alone, we cannot cut it. It is the smallest unit that we cannot cut it or stretch it or squash it. This means that a solid cannot get bigger on its own. If you left any solid state matter, it cannot become bigger. If you left your book, you found data bigger in size or shape. Sabah?
Yeah.
If you left your book or notebook, you can find it the next day bigger in shape.
No.
No. So it keeps shape. It keeps its shape and mass and volume. Okay.
Okay.
This is what the solid state matter. The particles of the solid state. حاسه ان انت النهارده مش مركزه شويه او تعبانه في حاجه؟
لا.
تمام.
ايوه.
Okay. Here, Paya decided to make her own model of a solid. Here, she is trying to represent the particles of the solid in a model, to make a model on her own. She used building blocks that could be joined together. She used these building blocks to make a model like this one. Each building block represents a particle. Can you see, Sabah?
Yes.
Yes. Each building block represents a particle. She brings these building blocks and make from them a model, simulates or similar to this model of for the particles of the solid. Okay. She used building blocks that could be joined together. Choose some building blocks, make your own particle model of a solid. Try squashing it. Can you squash it?
Squash the building of the
Squash this
cubes?
model. This model, can you squash it?
Yes.
Not to make each building block alone. Squash. Squash
No.
means to crash it.
No.
It's hard to be crashed.
Yes.
Try to pour it. Can be poured like liquids?
No.
No. Try making it take up more space. Can you make it take up more space?
Yes.
Without moving this building, without moving any building block as it is, as a whole. You can make
No.
you can make it take more space. No, it take its space and its mass volume are the same. Does the model match the scientist's idea? Does this model similar to this model or give the same idea?
Yeah.
All the properties here are present here.
Not all.
What is the absent property?
This one is making like a cube. This is making like a rectangle or like this.
Okay, okay, but the thing that the building blocks can't represent is the vibrating movement. Here, the particles are vibrating. Here, they are not vibrating, they are still. So here, this model doesn't represent the movement of the solid particles. Okay, Saba?
Okay.
This is the solid state matter and the particles of the solid state matter. They are baked together, fixed in their place. There is a pulling force between the particles, keep them in the place. They only move by vibration. And they are arranged or tightly baked in a neatly way. Okay?
Okay.
ده تمام. ننقل على حاجة تاني؟
لا.
لا ما ننقلش.
لا ننقل كنت حاجة تانية.
Okay. We talked here about the solid. We'll talk about the liquids. We'll show the difference between the particles of the liquid and the particles of the solid. Liquids have some different properties to solid. Can you tell me the difference between liquids and solids without talking about the particles? The difference between solid and liquid. Yes.
The solid is a liquid is something we can put it in a bottle. We can drink it.
Pour it.
Yeah, pour it, or we can make it solid, but we cannot hold it.
Yes, it can't keep its shape. It
Yes.
needs a container to keep its shape. The liquid alone can't keep its shape. Liquids need a container to hold them. They take
Yes.
the shape of the container. Without a container, a liquid will flow. If we left water on the surface of the table, it will flow and it will spread all over the surface. Unlike the solid, if we left the solid on the table, it can't flow. It stay and keep its shape. It doesn't need a container to keep it or to keep its shape. Again, we need to imagine how the particles are arranged. We need to imagine the particles of the liquids. What is the arrangement of the particles of the liquid? Here, talk to a partner and draw your ideas about how you think the particles in a liquid are arranged. These questions may help you. What can a liquid do that a solid cannot? Can you tell me, Saba? What the thing that the liquid can do, the solid cannot do?
The liquids we can drink it, the solid or not.
We can what?
The solid we can put it in a container. The liquid we can put it in a container.
Yes. يبقى the liquid can flow. The liquid can't flow. The solids can't flow. Okay. B. Do you think the particles are in fixed position? The particles of the liquid. Do you think that they are in a fixed position?
Yeah.
Fixed in their place without movement?
No.
Okay. They are not fixed. They are fixed or they are not fixed?
They are not fixed.
Okay. C. Do you think the particles can move?
The particles can move, yes.
Yes. Why do you think that they are moving? Because the liquid, if we lift it, it flows.
It flow down at the surface.
Yes, it flow. This flow is due to the movement of the particles. If their particles cannot move like the solid, if we lift the liquid, it can't move. But because due to the particles of the liquid can move, we can't lift them without container. So do you think the particles can move? Yes. Why? Because they can flow. If we lift them, they flow. They usually need the container to put them in it. Okay?
Okay.
If the particles can move, do you think they move more or less than particles in a solid?
More. They
More.
move more.
Yes, very good. They move more than the solids. Okay. Here, two learners draw their ideas and wrote some answers to the question above. Compare your answer and your image to the one on the right. Okay, they said what? They say that a liquid can move and flow. If a liquid flows, perhaps the particles flow as well. This is the answers for this question. They think that the liquid move and flow. Perhaps the particles flow as well. As the liquid as a whole flows, so its particle must be flowing particles. Okay?
Okay.
We don't think the particles are in fixed position. This is the answer for B. Do you think the particles are in fixed position? They said no. The particles are not in a fixed position. Type C. Do you think the particle can move? They are not closely baked. They are talking about the particles of the liquid. They said that the particles of the liquid are not closely baked. They are not near to each other. So they can move about, can move around each other. D, if the particles can move, do you think they move more or less? They think, or we think they move more than solid. This is the answers of the learners. Do you think their answers is true or false?
True.
True.
False. True.
Repeat, please. Say it again.
That true.
True, okay. What is the idea of the particles in a different state of matter called? Can you remember, Saba? The idea that the scientists have, the idea of the particles in different state of matter, they called it what? Particles model. Particles model. Okay. Now we will talk about the properties of the particles of the liquids. Here is the particles of the liquid. It is different from the particles of the solid. Can you remember? This is the particles of the solid, and this one is the particles of the liquid. Can you see the difference between the arrangement of the particles, Saba?
Yes.
This difference in arrangement makes the solid differs from the liquid. In a liquid, the particles can move about, can move around each other, as the arrows. Can you see these arrows?
Yes.
It tells us about the movement of the particles. In a liquid, the particles can move around each other. The particles can flow around each other and slide over each other. Slide, do you know the slide in the club?
Yes.
Yes. The particles make the same movement. They are sliding over each other. Sliding. When you pour a water on the surface, it flows. This flow, we call it sliding. It slides over the surface. So the particles also slide over each other. Okay?
Okay.
So the whole liquid can move. So the movement of the particles, or the sliding movement of the particles, makes the whole liquid state matter slide over each other. Okay? Okay, Saba? Okay. The particles are not neatly arranged. They are not arranged neatly in a neat way like solid. Can you see the solid? The particles are arranged, the row over the row, the column near the column. The particles are near each other. The pulling force between them is very strong. Here, the liquid are not the same. They are not neatly arranged in rows, but they are all still touching each other. They are near to each other, but they are not arranged in the same way. The spaces between them is not big. The spaces between them is small. All the particles are touching each other, but they are not arranged neatly in the same way as the solid state particles. They are randomly arranged. They are all over each other in a random way. Okay? Random يعني عشوائي يا صبا.
Okay.
Arrangement is random. Random, they are not in rows and columns in a neatly way. They are arranged randomly. They are all still touching each other. They are touching each other, but they are not arranged in the same way like the solid state particles. They are pulling each other. They also have a pulling force. The particles between each other has a pulling force, but the pulling force here is smaller than the pulling force between the solid state matter. The solid state matter, the particles have a very, very strong pulling force between each particle. Here there is a pulling force, but it is in small, يعني it's not strong like the pulling force between the solid state particles. They are pulling each other in a similar way to a solid. The particles cannot escape from the liquid. It's also like the solid particles. Each particle cannot escape alone. The liquid particles also cannot escape alone. We can't find one particle moving alone without the other particles. They are all connected or attracted to each other. Okay?
Okay.
The particles cannot escape from the liquid. A liquid doesn't change the amount of space it takes up. The liquid keeps its volume. It can't keep its shape due to the flow movement of the particle, but it can keep its volume. The volume is the amount of space it takes up. Okay, Sabah, the volume is the 1 liter or 2 liter, 500 milli. This is the volume. This is the volume. The liquid can keep it, but it can't keep its shape. Okay. Sabah, سامعاني؟ Sabah?
I can't hear anything. الصوت كان بيقطع قبل كده. أيوه.
دلوقتي سامعاني؟ سامعاني يا صباح؟
أيوه.
Okay. I was saying that the liquid doesn't keep
أيوه.
its shape. Yes, okay. The liquid doesn't keep its shape due to the flowing movement of the particles. The particles are moving around each other and they flow. So it can't keep its shape due to the flowing movement of the particle. But the liquid can keep their volume. Their volume and mass are definite. They can keep it. The volume is the amount of space that the particle take. The particles of the liquid can keep the volume. If I have 1 liter of a liquid, the milk, water, anything, it keeps its volume. When I pour it from one bottle or a container to another container, it keeps its volume. It can't keep its shape only due to the flowing movement of the particle. It also keeps its mass. So the liquid keep their mass and keep their volume. The only thing that they can't keep is their shape. Okay?
Okay.
So this is the properties of the particles of the liquid. They are moving, they are in a flowing movement around each other, as this arrow shows. They are flowing around each other. They slide. Their movement is sliding over each other. So the whole liquid, when we pour it on a surface, it flow. It flow like the movement of the particles. And the particles of the liquid are not neatly arranged in rows like the solid state particles. They are randomly arranged around each other. But they still touching each other. And particles are near each other, but they are not arranged in the same way as the solid state particles. They have also a pulling force between them, but it is a weaker pulling force than the pulling force between the particles of the solids. The pulling force here